Hello everyone, let's go to the 136 example. Make a function that takes a number n and returns the number of prime numbers smaller than existing n. So let's go to the program and see what is happening here. First of all, I am include the library stdio.h, which allows us to print messages on the screen and use a lot of basic functions on the C language, such as scanf and printf. Here is just a comment of our function that will return an integer variable, and every time I call the name primes will be a reference of our function, and this function will have a seed, and this seed is integer n. In the main function we will include two int variables, the n and the answer. This printf is asking to you to enter an integer, and this scanf will storage the value that you type in your keyboard on the computer memory. The answer will be equal to primes with the seed integer. This printf is just print the answer and then return 0. So let's go to the primes, the function primes, to see what is happening here. First of all, I have the seed n that I read for the keyboard, the input, and then I seed the function with the integer. Here I am setting 4 integer variables, the quantity, the I, the j, and the check. So, first of all, let's understand what is a prime number. A prime number is a number that is only divided by itself and 1. So, 7, for example, is a prime number because it's only divided by 7 and 1. So, here is the core of our program, and this is the way of thinking that I am getting to choose if it is not or if it is a prime number. So first of all, I am starting with the value of I equal to 2, and the value of I has to be lower or equal to n, and every time this runs, the value of I will be increased by 1. Here I am making the variable check equal to 0, and this for loop is the division. So the j is equal to 2, the j has to be lower than 1, then and every time this circle runs, the value of j will be increased by 1. So what is happening here? For one value, for example, for 3 here, we will divide all the values in the range 2 and 3 minus 1. So in the range 2 and I minus 1, we are checking if it is divisible, because this range is a range of that any number that is divisible is not a prime number. So the I remainder of the division by j is equal to 0, the check will be equal to plus plus, and then I will check if the value of the check is equal to 0. If it is a prime number, and then I will increase the quantity. So why? I remainder of the division by j is equal to 0, because, for example, we have 4 here and 2 here. I remainder of the division by j for remainder of the division by 2 is 0, and 4 is not a prime number. Just that. And then I will return the quantity plus 1 because we are not using the 1 here, and then we will get 4, for example, 7. In this, 6 and 7. So here we have five prime numbers, 1, 2, 3, 5, and 7. As you can see, 5 numbers. And then this function, the quantity here will be just for the 2, 3, 5, and 7. That's why I am increase 1 value. So let's go to the terminal and see what is happening here. Enter an integer, 7. As you can see, the amount of prime numbers in the range 0 to n is 5. Let's set another value, 11. 11, 6, 13, 7. So this is pretty much for this content. Thank you for your attention. Link for the script is on the video description and subscribe for regular content.